For our last example in section 10.3, we're going to look at number 62. They want us to find the equation of the ellipse, and they're going to give us some information. They're going to tell us that the center of the ellipse is at 1, 2, that one of its focus points is 1, 4, and that it contains the point 2, 2. Now there's others before this that are a little bit more straightforward in what they give you, but I think those are done well in the book, so I just wanted to do one that was a little bit different, and that is that it's not giving us a vertice. So typically the ones previous to this gave us a center, focus, and one of the vertices. That was enough for us to get a lot. This should still be enough for us to solve, so let's see how. Well, notice what everything's happening to. Everything's happening to the y. So it doesn't matter then whether you put x or y first, so I'm going to just stress by putting the x first and do x minus 1 squared, and that's going to be over something plus y minus 2 squared, and that's going to be over something, and that's equaling 1. Now what I do know is that the y has the bigger value under it, so I'm going to put the a squared underneath the y. Okay, so I'm going to always let a be my bigger value. And it's definitely underneath y because to move from the center to the focus was a shift in the y direction. Well, here's what I know. I know that that 2, 2 is on the point. Now that's not, or on the curve. That's not a random point. Let's draw a picture of what's going on here. We have a center that it's at 1, 2, a focus that is 2 higher than that, right? So that's why I'm claiming. So it looks something like this, right? Because that focus point is inside the ellipse. So we don't have any of the vertices, but it does contain 2, 2. Well, where's 2, 2? Well, that's 2, 2 would be here, right? So notice that your y coordinates match. So when you look at your center was at 1, 2, and your y coordinates was 2, 2. Well, that's a distance of 1. This information right here is telling me that b is equal to 1, which tells me that this part under here is now 1 squared, or 1. So we got a b is equal to 1, so b squared is also equal to 1. How did I know that? Because to move to the center directly to the right was a distance of 1, because 2, 2 is right there along that straight x-axis. Well, that's what I needed. I need some way to get one of those two values. So now what do I know? I know c squared is equal to a squared minus b squared. Well, we know what c is. C was the change as we went from 1, 2 to 1, 4. So C was a change of 2. So C is 4. And that's equal to a squared, what I want to find, minus b squared. And so what's a squared equal to? A squared is equal to 5. And so what's the equation of the ellipse? Well, let's just come in here. And remember, we could care less what a is because we're after the equation. We are happy to know a squared, and it looks just like that.